Hello, this is Professor Zaman. Welcome to Hasan Zaman educational video series. This video is in our DC circuit series. Let us continue our discussion on series parallel circuits. Here we will look at some tricky situations. So 12 volt battery, 2 ohm resistor, let's add the round node here. We have to minimize the circuit first to find one single equivalent resistance to find the source current. These two are in parallel. Equivalent resistance of these two will be 4 by 2 is 2 ohm. So in total it will be 2 plus 2 plus 2, 6 ohm resistance. So the current will be 12 by 6, 2 ampere. The 2 ampere current will go through this way, and through these parallel networks come back, and it will also have 2 ampere current. But what will be the current here? These two resistors have the same value, so the current will be split equally. So we had current of 2 ampere, so that means this will have 1 ampere current and this will have also 1 ampere current. Now let's make it a little more complicated. So if we add one more resistance here and one here, so let's make them also 4 ohm. Okay. Now what is the total resistance? Now we have 4 resistors which are same in value. That means the total resistance will be, take one of the values 4 ohm and divide by the number of parallel branches. So 4 by 4 is 1. So the equivalent resistance of these 4 resistors is now 1 ohm only. And that 1 ohm is in series with this 2 ohm and this 2 ohm. So it's totally 5 ohm. The current will be 12 volt by 5, 2.4 ampere current. And what will be the current through these branches? 2.4 ampere current will go this way and will come back through this resistance to the source. And after coming here, the current will be equally split. That means each branch will have 0.6 ampere current. Now let's add one more trick. What happens if we add another branch, but this time not a resistor, like this? That means the resistance of this is 0 ohm. We actually call this a short. What is the total resistance of this parallel combination? 1 over 0 equal to 1. This will be 1 over 0 is infinity plus these values, these 4 values. But if we add anything to infinity, it remains infinity. So equal, and 1 over infinity, that is inverse of infinity, is 0. So you can replace all these resistors with 0 resistance. The current after coming here, you found a short path, no resistance. So the entire current will flow this path. So there is no effect of having those 4 resistors here. Having them or not having them doesn't make any difference in the circuit. So that's why the equivalent value is still 0 ohm. So the current will be 12 volt divided by 2 plus 2, 4 ohm, that is 3 ampere current. So this is an important thing to understand, that when you have a short branch, all other parallel resistors have no effect in that case. Now this short can be added in many ways. So we had these 4 resistors. So this is kind of easy to understand that this is causing a short. What if it was not like this? Say it was like this. Will this be different? Actually, this is not any different than what we just had, because the still current after coming here, it can go entirely through this short path and come back. So this is again in parallel with these 4 resistors. So this thing can be replaced with a short circuit, just like before. Or you can add another short here. If we add one short or multiple short, doesn't matter. So still the whole thing will be equivalent to a short. That means current will still be 12 by 4, 3 ampere. Or if we had just one like this, still the same case, 12 by 4, 3 ampere. So this is very important to understand the effect of short in a series parallel circuit. Draw it a little differently. Suppose let's say this is 4 ohm, 4 ohm, 4 ohm. Suppose you have a connection like this. What will happen? I will give a few seconds to think. So you have to look at the path of the current. So after current coming here, it can go this way or it can go this way. But after coming here, it has this path, or this path. So that means this path, and this path are in parallel, and one of them is short. So that means this entire thing can be replaced with just the short. So that means it has no effect, this has, and this has no effect. Now what is the structure of these two? I think you have guessed correctly, they are in parallel, because current after coming here, it is split into 2 parts. One part goes this way, other part goes this way. 4 and 4 parallel will be 2 ohm. In total will be 2 plus 2 plus 2, 6 ohm. Current will be 2 ampere. Let's look at a different kind of series parallel circuit. It's called ladder circuit. I have a voltage source, 12 volt. So let's assume this is 2 ohm, 1 ohm, 1 ohm, this is 4 ohm, 1 ohm, 1 ohm, this is 4 ohm, 1 ohm, 1 ohm, 4 ohm. Let's add one more resistance here. 1 ohm, 1 ohm. So this looks like a ladder, but solving this circuit is nothing different. We use the general technique of solving series parallel circuits. We start from the farthest end, from the voltage source, and you can see that these 3 resistors actually in series. So that is 1 plus 2 plus 1, 4 ohm. And that 4 ohm is in parallel with this 4 ohm. 4 and 4 in parallel means their equivalent resistance is 2 ohm. That is 4 over 2. So this 2 ohm is in series with 1 ohm and 1 ohm. Again 4 ohm. And that 4 ohm is in parallel with this 4 ohm. So it becomes 2 again, 2 ohm. And that 2 ohm is also again in series with this 1 ohm and this 1 ohm. Becomes 4 ohm. And that is in parallel with this 4 ohm, becomes 2 again, 2 ohm. And that 2 ohm and this 1 ohm and 1 ohm, again 4 ohm. Total resistance is 4 ohm, and current will be 12 by 4, 3 ampere. And this 3 ampere, after coming at this node, it has two paths. This is 4 ohm path, and the right side is also 4 ohm. So it will be equally split. The current here will be 1.5 ampere, and this will be also 1.5 ampere. And this 1.5 ampere will see 4 ohm here, and also right side 4 ohm. It will be again split in half. So this will be 0.75 ampere, and this will be 0.75 ampere. Again, this 0.75 ampere will be split in half because this is 4 ohm, this is also 4 ohm. So this will be it will be 375 ampere, and this will be also 0.375 ampere. So even though it's a long circuit like a ladder, but the solution technique is nothing new. We solve it the same way we solved other series parallel circuits. That brings us to our last topic. Sometimes even a simple circuit can look tricky because of this construction. So let's draw a simple circuit first, then we will make it a little more complicated. So ground. So what will be the source current? 2 and 2 in series, so 4 and 4 in parallel, that is 2 ohm. That's 2 ohm is in series with 2 ohm, total 4 ohm resistance. So the current will be 12 by 4, 3 ampere. Let's try to make it a more complicated. Let's make this a short. What will be the current now? Then figure out current will come this way, and it will see a short path. So these resistors will have no effect at all, as if they are not there. So this is the only way current will come back to the source. So this is the only resistance in the circuit. 12 by 2 is 6 ampere current. Let's add one more resistor. What happens now? Let's say this is also 2 ohm. If you try to trace the current paths, you will still be able to figure out which is in parallel and which is not. Let me give you a clue. You can say that these two resistors are in parallel. Why? The parallel resistors always have the ends connected, both ends. You see, this is a connection point, and this is also a connection. So even though that may not be easy to see in the beginning, but if we apply a technique, redraw the circuit in a little different way, that will be much easier to see. So to do that, what we will do, we will name the nodes. We haven't really discussed much about what a node is. So in electrical circuit, a node is basically where you have same voltage and no other element in between. For example, if you call this a node A, and this is a node B, what is the node? What is this node? This is also B because it's connected, nothing else. Let me write it correctly. And what is this node? This is also B. What is this node? Now this is a different node because it is not connected to either A or B. There is a resistance in between. So we will call this C. So in total, in this circuit, 3 nodes. So if you redraw the circuit using these 3 nodes, it will be easier to understand. So let's first draw the voltage source. 12 volt. and we will draw the nodes as they were there. So this is A, this is B, and C is here. Okay. The only difference will be in this drawing. We'll draw all the resistors between the nodes. Let's first draw this resistor. 2 ohm is between A and B. So let's draw this between. We will not draw it like this. We will draw between A and B. So this is out of the way. Now, where is this resistor between A and C? So we will draw that. This 2 ohm is. Let's name the resistors so we don't get confused. R1, R2, R3, R4. So this is R1, this is R4. Let's draw R2. What is R2? R2 is between B and C. So we'll directly draw R2. The only one remaining is R3, which is between, again, B and C. So we already drew here, so we have to draw in parallel. This is R3. Okay? Now it will be much easier to understand. You see, these two are in parallel. That is in series with R4. And the whole thing is in parallel with R1. If you put back the values, R4 is 2 ohm. Actually, all of them are 2 ohm. So what will be the total resistance? This 2 ohm and this 2 ohm are in parallel. That is 1 ohm. 1 and 2 ohm are in series. So it will be 3 ohm. The 3 ohm is parallel with 2 ohm. If you use product over sum formula, 3 times 2 is 6 and 3 plus 2 is 5. So 6 over 5 ohm, which is 1.2 ohm. Total resistance is 1.2 ohm. So the current here will be 10 ampere. 12 by 1.2, 10 ampere. Okay, so even though this is a little more complicated to understand, when you redrew it using the nodes, it became much simpler. So we'll do one more example of this nature. This will also have some trick, but I think it will help us understand how to solve a bit complicated circuits. We will erase this. So we'll make this a short and add a resistor here. So we'll call this R4. This is, let's make this 4 ohm for a change. Now, how many nodes in this circuit? Let's first erase this. So A and B, you have 2 nodes, 2 end of the battery. What is this node? These two are still the same B node because they are connected. What is this node? If you look carefully, you will see this connected to the A actually. This is A. Only this node is a new node, a different node, because this is not connected to A or B. So we call this C. So just like before, if we redraw this circuit, we first draw the 12 volt source. Then we draw the 2 nodes. A and B. We have a C here. Okay. Now we'll draw all the resistors between the nodes. First, let's draw R1. R1 is between A and C. So R1 is 2 ohm. Let's draw R2. It is between A and C again. So R2 is still between A and C. And we already drew this here, so let's put it in parallel. So R2, 2 ohm. Now R3, what is R3? R3 is between A and B. Between A and B. So R3 is between A and B. That is also 2 ohm. We are left with only one resistance, which is R4, which is between B and C. So B and C is R4. And that is a 4 ohm. So the trick is, a node here looks like a node, it's a point. Here is distributed, so it confuses us. So if we make a node a point, then it will be easier to figure out the structure of a circuit. So let's look at this circuit. I guess it's pretty easy to follow. What is the structure? These two obviously are in parallel. So 2 ohm and 2 ohm in parallel, combined resistance will be divided by 2, that is 1 ohm. And that 1 ohm is in series with this 4 ohm. So total is 5 ohm. And 5 ohm is in parallel with 2 ohm. So what will be the total resistance? Product over sum. 5 times 2 is 10, divided by 5 plus 2, 7. So 10 over 7 ohm is the total resistance. So now you can find the current here. To divide 12 volt by the resistance 10 over 7 ohm. You can use current divider rule to find all other currents. There will be 12, here it will be 2 split. One part will go this way, other part will go along this way. But that part come back to through one resistance, but here it will be split again. And equally split because they are same resistors, these two, same value. So we have covered many series parallel circuits with tricks like this, shorts or irregular structures, and we have found the common way to solve or understand the circuits. That is redrawing the circuit using the nodes not distributed at points, and draw the resistors between the nodes only. That will really help you understand the structure of a circuit, and you will be able to solve it. I hope you enjoyed watching the video, and you will practice more. It will make you much more confident about solving these circuits, because this will build foundation for solving complicated circuits, and you will enjoy this challenge. Thanks for watching.